Okay, so for the first 10 minutes of this class, I want you to go ahead and look at these three particular lines. Okay? I already have the points for you. I already pick out the points. Technically, if I don't pick out points, you should try to pick out your own points that will help you solve the problem efficiently. Okay, so usually you would definitely going to pick points that is right on the crosshair of the graph, because that will give you whole value. You know what I'm saying? You don't want to have to estimate, oh, it's about 2.5. No, it's not the point. I want to make sure it's actually good points. Talk like whole numbers. What I want you to do for each particular line, notice I have three different colors, so I want you for each color line to find the equation, first of all, in slope-intercept form, and then convert the slope-intercept form back to the standard form. Okay, now do you see my requirement? Slope-intercept first, then the standard form. Okay, so go ahead, you have 10 minutes to work on these three lines, and then we're going to have a discussion after this. Go ahead. With the purple line, I gave you two specific points. Is that correct? So if you look at the two specific points, perhaps I should minimize this a little bit so I have room to work on this. Here we go. Okay, so there. If you look at the purple line, the first 2 points that I see is this, which is at -3 and 3. So we agree. I look at the other point, it is at 3 over to the right-hand side and what? 1, 2, 3, 4, 5, 6, 7 up. Is that true? So you write 3, 7. If you cannot even identify the points correctly, then guess what? Can you ever get the equation correct? No. Okay, fine. So we get the 2 points. And yes, you can go through and do your subtraction problem to get the slope. So I'm going to start with this. Here's -3 and 3. Here is 3 and 7. I go ahead and subtract here to find my slope. -3 minus 3 is -6. And 3 minus 7 is -4. Okay? So I put rise over run because the format of the slope is -4 over -6, right? Please don't leave it like this. First of all, it's not simplified. How do you simplify -4 over -6?
Divided by 2.
Okay, divide by 2, which makes it 2 over 3. Right? And notice, because it's a negative divided by negative, I know it eventually becomes a positive. And how do I know my slope is correct? Verify it by going back to the line right here and say, wait, so that means I have to go 2 up, 3 over. Did I land on the point? Yes, on the line? Yes. So I know that's correct. 2 up, 3 over. Look at that. That's how I know it's correct. I go back to the line and verify that if I go 2 up and 3 right, I will also land on another point on that same line. Okay, so I got my point right. I mean, I got my slope right there. Okay? How do we write our equation? Well, first of all, you can decide. Do I want to start with slope-intercept right away, or do I want to start with point slope? Well, if I look at what's given to me, I have 2 points, but do I have the y-intercept given?
Yes.
Yes or no? No. So let's say it's not given. Pretend it's not. Then I will start with this form, which is called, what is this point called? Form is called point slope form, right? And I just basically plug in what I have. First of all, I have the slope to be 2/3. Is that correct?
Yeah.
I replaced m with 2/3. I also have in here, in this case, which point should I pick to make it easier for me to calculate? The 3, 7? Okay, so I'm going to plug in where, what here? 7 over here, and I'm trying to make it easier for you, and here you are, it's struggling through it. It's not supposed to be like that. It's a preset form where you just plug in information. Okay, so watch. I'm going to go ahead and move up the 2/3 into the m here. So to complete this, this is called point slope form, which is not the slope intercept yet. How do we get to the slope intercept? We solve it by, go ahead and first distribute, right? Which becomes what? Y minus 7 equals to 2/3 x minus what?
2.
2. And then we add the 7 over. This becomes y equals to 2/3 x plus 5. See that? That's what form is it in now? The slope intercept form. Now we want to take this form and convert it back to standard form. What's the next step after this?
Move all the variables over.
Move all the variables to one side. So specifically, what should we move over?
2/3.
2/3 x. How do we move the 2/3 x over? Subtract it. This is the entire term, right? If we want to take the entire term and move it to the other side, we only have two options: adding or subtracting over. Never multiply and divide. I don't know how many times I have to say this. Maybe a million times I know it until I die. But that's what I'm saying. If you are going to be grabbing the entire term to move over, never divide or multiply. It's adding or subtracting. It's like removing one block from the basket. You don't multiply divide it, do you? You actually take it away, meaning subtract or add it over here. I never use, oh yeah guys, go ahead and multiply that block and divide it over here. You don't say that, do you? You say, oh, you're going to remove that block, whole block, and add it over here. Did I ever use the word multiply divide? So that's what removing entire term is. Okay, so now we have it. We got negative 2/3 x plus y equals to 5. Do we agree? Is this the form that we want?
No.
Okay, what are the two rules we specified yesterday?
Has to be an integer.
Yes, has to be integers, and the first term has to be
Positive.
positive. So how do we eliminate the fraction here?
-3.
Times it by -3. Because if you times it by the common denominator, and of course take the opposite of what you see here, you will guarantee to get a positive back and no fractions, right? So this becomes 2x minus 3y equals to 5.
-15.
Oh, sorry, -15. Sorry. See? Common mistake, right? You tend to forget certain stuff, but you're right. -15. Any questions on that one? So let me go ahead and write this information down for you so that you can see this later on. So the standard form for this is 2x minus 3y equals to -15. And the slope intercept form is y equals to 2/3 x plus 5. Any questions here on the purple line? Is this like completely new to you? Or have we done this so many times already? Mark? Did we do this before?
Yeah.
Yeah, and so what happened? Brain freeze?
I didn't know what it was called. Didn't know what to do.
Okay, that's why you need to refer back to what we covered yesterday, right? You don't just stare at a blank piece of paper. Is that true? Okay. All right, moving on. So get that information down, and I want you to look at one thing as well. Yes, I did it the hard way. I didn't really utilize what was given to me. But if you notice, if you look closely enough, look at the purple line again. Did it cross over the y-axis? Look at where it crosses over. What point did it cross over on the y-axis? 5. Look at this. We went all the way to find the y-intercept, but technically, if you look hard enough and you see if there is a y-intercept already given to you, or if you can actually spot it, you can rewrite it right away, isn't it? So for the orange and blue line, let me show you that technique to get it done quickly. Watch this. Let's do the blue line. Yes, I give you 2 points, but this time, notice I give you, what is this point here? I give you the y-intercept already. And yes, you can actually do the slope by getting the 2 points and subtract, right? But didn't we also know that we can actually obtain a slope from the graph by using rise over run technique? All we have to do is start from the point from the left and try to move to the right using rise over run. So think, how do we get from here to here using rise over run? Up how many? 1, 2. Do we stop here? So up 4. Now what?
And go to the right.
1, 2, 3, 4, 5, 6, right? So 6 right. So rise over run. Reduce to?
2 2/3.
So just like that, we got ourselves a slope and y-intercept. So do we need to put it back in point slope form anymore?
No.
We don't. We can just go and start with this. Y equals to m times x plus b. And yes, here we go. You got student all confused at this point, don't know what to plug in. What do we have? A slope and a y-intercept. So which two variables should we replace those with?
M and B.
So Zuko here said y and x. Is y your slope?
No, it's me. Why?
Huh? What should we replace with?
Yeah.
M and?
B.
Okay, what's given already?
Again by F.
And
Y.
what is this point called?
Y.
Which letter represents the y-intercept? B. Okay, so we all that we go back on is, okay, I have 2/3 for the slope, and the B is? What is the B?
-3.
Right? You don't see that. You don't see that this point is at 0, -3. Huh?
I see.
You don't, or you do?
I do.
Okay, and you know why it's -3 here?
Yeah.
Why?
Because
And what is that point called?
Y.
And do you know why we put the -3 here? You don't know why we put the -3 here? And do you know what the B stand for? Okay, let's go back to it again. What form is this called again?
Slope intercept.
You know what this whole thing's called?
Yeah.
What?
Slope is
Oh, okay, slope intercept. Do you know what the M is? Okay, so you know the M is the slope. Do you know what the B is? Okay, let's call this form again. What's this form called again? Okay, so if this is a slope, what do you think this is? Take a guess. Okay. Intercept. What's intercept? X or Y? Okay, so is this the y-intercept?
Yeah.
What point is it? And do you know why I put a -3 here? So what is this -3 again? Thank you. All right. We're good with that? Yes.
Why is there not a plus sign?
Okay. I'll show it to you. To make you happy. What is a plus and minus going to become? Is that so? The same? Right, that's why. Because a plus might become a minus anyway, so that's why I don't put a plus there at all. Okay, but how do we put this back to standard form?
Minus negative.
Move the variables to the left. So I move this. So kind of same case to from the previous problem, right? So minus 2/3 x over plus y equals to -3. Agreed?
Yeah.
Okay. And how do we clear our fractions?
Times it.
Times it by
-3.
-3. So same exact thing. So it's going to become
2x
2x
minus
minus 3y equals to 9. So I have the information here. Let me just go ahead and erase this, make room for it. And I'm going to write the information right here for you to see. I have the y-intercept form to be 2/3 x minus 3. I have the standard form to be 2x minus 3y equals to 9. So we got the purple down, we got the blue down. We have the orange to take care of. Let's take a look at the orange. Okay, what's given on the orange, please?
the y-intercept.
The y-intercept. Ooh, what is the y-intercept again? I want to make sure. The y-intercept is what on the orange?
0, 8.
0, 8. So can we just put 8 there for the y-intercept because b is 8? Do we have to set up the subtraction problem to find a slope, or can we just use the 2 points to find a slope?
2 points.
Okay, so let's take a look. If we start from here and try to get down to here, how do we move from here to here using rise over run technique? What would you do? How do you start from here to go down to here? Okay, so you go down how many? I kind of give it away, huh? I said from here down to here. So the first step is to go down or up.
Down.
Yeah. And notice over here when I say from here up here, I kind of give that away too when you say it. I want to move from this point up to that point, so you have to go up first. I want to go from here down to his point, so I have to go down first. You see that? How many?
5.
Okay, let's count. 1, 2, 3, 4, 5, 6. 6 down. Equals to 6 down. How many over? You don't count the square. You actually count the crosshair. 1, 2, 3, 4. So 4 right. So can we reduce that? Which becomes?
Negative 3 over 2.
-3 over 2. Okay, so we got our slope, we got our y-intercept. What can we write this as? Okay, so y equals to m times x plus b. Let's test this again. What do we replace this time?
M and B.
M and b. What do we write the m for with? What do we write here? Negative 3 over 2x. Very good. What about the b?
A is 8.
So we just plus 8, right? Okay, so this is our slope-intercept form. How do we put this back into our standard? Add 3 over 2x over. Very good. So it can be 3 over 2x plus y equals to 8. How do we clear our fractions? Times 2. Common denominator. You end up with 3x plus 2y equals to 16. So let's sum it all up again. For the orange line, I have y equals to negative 3. Oh, I have negative 3 over 2x plus 8. And the standard form is 3x plus 2y equals to 16. Okay, any questions so far on what I just did? Do you notice that from standard form I can always go back to my slope-intercept, right? By solving for what? If I want to go back from here to here, what do I do? Solve for y again. You see that? Meaning move the x back, so undo what you did before. That's it. Okay, any questions so far? All right, let's clear it up a little bit, and I want you to kind of help me analyze a couple things. First, let's compare purple and blue line. What do you notice about the purple and blue lines? What do you notice about the two slope-intercept form? What do you notice? What's the same? What's different? The slopes are the same. The y-intercepts are different. Look at the standard form. Looks exactly the same on the left-hand side with the variables, huh? The only thing that's different is the number on the right-hand side. Now, what we just achieved right here, guys, I know I didn't explain to you what it was early on, but notice that whenever we have two lines that have the same slope with different y-intercepts like this, and what do they look like to you, to be honest? Parallel. And you were right. They are actually parallel, so to really sum this up, this is what I want to conclude. For parallel lines, please write this down. You'll have same slopes and different y-intercepts. Okay? Those are for parallel lines. Basic rules. So that means if I give you a line and I say, okay, the slope is 5, for example, and I ask you, go ahead and define another line that's parallel to the previous line, what do you think the slope of that new line is going to be, if you know it's going to be parallel? Let's say the previous line is 5. Slope is 5. What do you think the new line is going to be if the new line is going to be parallel to the previous? 5. Same slope, right? And of course, usually I would just give you a point. Say, I want you to go ahead and have that new line cross over this particular point. Then you can just use the slope and the point to write an equation. Now let's go ahead and sum up the orange line with the other two lines. First of all, the orange line in this case is actually cutting right through the two lines, blue and purple, at a 90-degree angle. And if we have that case, we call this perpendicular, right? Okay, so perpendicular case. When we have a perpendicular case, look at the slope, please. Compare the slope of the orange line to the previous two lines. What do you notice about the slope? Okay, so first of all, they flip and they're opposite. So can we just go ahead and sum it up like this? Slopes are opposite and reciprocal, right? That means they're flipped. So you take the opposite first and then reciprocal of the slope. So that's why when we have over here, notice we have 2/3. The other equation we have flip, 3/2, right? And then negative, because we have to apply opposite reciprocal. So slopes are opposite and reciprocal. So for instance, imagine if my old line has a slope of 5, for instance, once again. And the new line is perpendicular to this particular line. What do you think the new slope is going to be? Think for a moment. If the new line is going to be perpendicular to this slope.
Negative 1/5.
Thank you. Negative, so you got to take the opposite, right? And then what is the reciprocal of 5? See, 1/5. See that? Because this used to be 5/1, right? So this is the slope of the perpendicular line, if I ever ask you to find it. Okay, now why is it so important for you to understand the difference between parallels and perpendiculars? Because tonight, for example, you are going to be finding equations of parallel lines and perpendicular lines. I don't give you the slope, but you should be able to figure it out by now, just by giving whether they are parallel or perpendiculars. If they are parallel lines, the slope will always be the same. What about perpendicular? Opposite and reciprocal. That's how you find a new slope. And the rest is actually the same. You set up your point, set up your slope to find an equation of a line. Okay? So let me go ahead and bring up your focus questions for tonight. Let's go ahead and stop.